I think it's probably just easier if I just wing it. I mean, what is XEPL? XEPL is software. It's C++ software that runs on pretty much any computer. It's really small, really light, really fast, builds quickly, it's easy to use, it's extensible, customizable. Um, Dang, that's a pretty good list of things. Well, it's a tall order, so let's start breaking it down. It's one file of C++. That's what I'm offering in this case. Seems like it's the easiest way to deliver software. I wrote a little build program that took all my C++ code, piled it together, then I cleaned it all up to offer you this demonstration of XEPL. XEPL is really just kind of an operating system for threads versus a operating system for processes. The difference between the threads and the processes would be that the operating system is trying to separate the processes from one another, while the operating environment, in this case, is trying to integrate all the threads together. So it's the same thing. We're still using all those cores, but in this case, we have no protection from one another. We don't want protection. We want integration. We want to be able to see the memory of each other. Multi-user computers are primarily the reason we have the barriers that are there for processing today. It's a great thing, don't get me wrong here. Distributed computing is a wonderful thing. These are all wonderful technologies that we have, but they're kind of born out of an accidental complexity. An accidental complexity because in the earliest of days, computers were incredibly small. So we packed our instructions, we packed our structures, we compressed, we did everything we could in order to cram more and more into a smaller and smaller space. But as you know, and I know, the computers have evolved considerably over the last 50 years. And with that evolution comes multi-cores, mega memory, integrated GPUs. That's the whole thing has changed, and so it doesn't really make sense to keep everything separated when the primary use of this single computer is, or this single process is, to complete some sort of a task. XEPL was designed to handle multi-threading tasks. Multi-threading tasks are, well, I don't know. It's you probably recognize it from clones, like in Star Wars or something. All those clones that are out there. It's typically the way we use the cores today. In my design, or in XEPL, you will do multi-agent development. It's actually distributed computing, but it's internal. It's in memory. I'm handling all the communications between your agents, allowing you to distribute that processing across those agents. With the multi-core, now all those agents are working concurrently and with a common set of memory. You're not going to believe how fun this is.